Hello. Today we're going to be talking about fine tuning and how it's probably still a waste of your time. We've talked about this before. It was one of our most watched videos. It still gets some pretty good traffic today. So it seems like a topic that is close and dear to many of your hearts. So today we're going to talk about a number of different things. First, we're going to talk about some new related studies that have come out related to fine tuning and what the efficacy of fine tuning is, as well as what the future of fine tuning might look like. We're also going to talk about some amazing new RAG capabilities that I think are going to really be a game changer if RAG is your kind of go-to way of teaching an AI model how to do something. And then finally, we're going to talk about hype and machine learning. There will be links in the description to go to whichever one of these is interesting to you. So let's first talk about some of these studies that have happened. One study that I find super interesting was this one around fine-tuning and its effect on hallucinations. Now, this is the actual paper. There's a link in the description if you wanted to go check it out. But effectively in this paper, there's this really great graph here that kind of summarizes a lot of the difficult to understand details here. But effectively, it talks about what an LLM already knows about some set of data, right? The LLM had some understanding of the training data, at least because these are general purpose models, right? So they have some introductory understanding of what the data looks like here. But then over time, as they trained in more data, that model became clearer and clearer in its understanding of the unknown data set, right? Until you approach 100. Now, the graph below shows the accuracy of the model as it goes over time. You can see that it initially had this kind of peak as it was being trained on new data it didn't know. But then at some point where this kind of dotted line is, it begins to take a turn for the worst. And the more it is trained on this unknown data set, the less accurate it is in general, and the more prone it is to hallucinating answers. And so this is a really interesting study because it shows that while like fine tuning is the way that we've thought about bringing data into an AI model, this is basically saying, hey, be careful because there's going to be a limit here to what you're able to do with that. So you could imagine that I have some problem that I'm trying to solve, right? And if this problem is really specific, right? Say this problem can really get boiled down to a very narrow idea or a very narrow point that needs to be solved. It's very deterministic. If its domain is like very specific, that it is only this small section that you will ever ask the LLM, right? And you ask the system for something within this very specific domain, then fine tuning, accuracy goes up, right? And that's within this space. But then if your question falls outside of this domain area, right, where you fall outside of the space that you've trained on, right? Because on a lot of the LLM solutions that we have today, we're asking questions that we don't necessarily know the user's going to ask. That's what makes the systems magic, right? But if you ask something out here, fine tuning makes it dumber, right? It knows less about the rest of the world, right? It knows a lot about this space down here, but around all the rest of this space, it really doesn't know as much, right? And so that becomes your question is, okay, should I fine tune something? It becomes, okay, am I dealing with a very specific domain where it needs to act a very certain way? If that's the case, okay, maybe. But if I am still solving something generally, I'm still creating marketing emails, or I'm still trying to interface with a customer as a customer support bot, fine tuning might not make sense because you may start to deal with more issues where it hallucinates. And you might be able to broaden your data set to make that domain wider, but that fine tuning data becomes very difficult to find and manage and maintain. And this becomes a data problem. And I think if you're a data scientist and you're looking at this, you're like, no, duh. That's just how data science works, right? You need good data. Good data is like super important here. And these are gaps, right, in the data, but it's really hard to cover all the gaps. And so that's why LLMs are very generalized, right? They can solve problems generally. We don't have to know all the gaps ahead of time. So that's something very beneficial here. The other research paper was done by Anthropic. And this paper talks about mapping the LLM's brain in a way. Effectively, they went through and could try to pick out different details of how the LLM thought they were able to map it pretty directly, and it was very interesting. And so you can see here, this is visualization of that mapping, but they were able to give it an idea, say like the Golden Gate Bridge, and then they were able to use that as a steering mechanism to influence its behavior. And so when you ask it, hey, what's your physical form? It has that idea amped up in its head. It's been reinforced with that idea. And so now it's like, I am the Golden Gate Bridge. I'm a famous suspension bridge. My physical form is this iconic bridge, and it just won't stop talking about the bridge and all the different aspects of it. And they can do this with a bunch of different things, right? They can ask it a whole bunch of different questions, push these influences on it, and it's much more likely to respond in a way that is intended, right? This is an influence on the LLM. This isn't training, right? This is being able to say, hey, for this specific idea, I'm going to tune it a certain way. And they were able to do this more interestingly with code errors. And so they would basically be able to find like typos in code. And they found like when typos happened, they could find what part of the brain was activated when those typos occurred. There's a typo here, which is, and that would trigger this error, right? This would trigger in its head, oh, there must be an error related to this, right? You're able to tune errors out of an LLM, which is just insane. Suffice it to say, this is completely changing the idea of fine-tuning even more dramatically, right? Fine-tuning is this process that is difficult to accomplish, and that's why I think it's a waste of time. It's a challenging tool to use. You need to have a very good understanding of what problem you're solving, and that problem needs to be a very specific problem that isn't contextual. It is not about teaching it something so that it can use that knowledge generally, because we've seen that when you teach it something and try and apply that knowledge more generally, it actually gets less accurate with the way that it communicates everything else. And in the future, we may not want to fine-tune even ideas. There may be a lot of different things that we can pull out of the brain and reinforce in an interesting way. And this ability to map the brain and map the brain for ideas is a very compelling idea for how we might improve these models in a very different way than we've even thought about. So that may be the future of fine-tuning, is just influencing LLMs. Now, even more recently, there's been some amazing new RAG capabilities coming out, specifically around caching context, which is basically this idea that you have an LLM, you've been giving it this big chunk of context effectively, right? To say, hey, here are the game rules for this game that I'm playing, and here's the state of the board. What's the next play, right? So the context is like the data that you give it to ask it a question. Now, caching of context is basically saying, hey, I've got part of this context that I always pass to the model, right? This could be your prompt that you pass as a system prompt. This could be just information that a user has, and a user's making a lot of different requests, and you might just cache that on behalf of the user. Now, this is just a really amazing thing, because if you're able to cache these, you're able to take some context and ask a lot of questions on it. One of the biggest problems that I actually see AI developers try and do right away is they have some context that they have, right? Say you've got game rules. And then what they do is they throw that through an AI model to answer a question, but they really can't help themselves. Most AI developers, the first time that they do it, they actually start asking a bunch of different questions, right? And you've definitely done this if you've coded with LLMs before. And so I'm going to ask it for these three things. And what you're going to do is you're going to have it return it as JSON effectively, right? You're going to ask the AI model, and you're going to say, hey, I want these three things. And the problem with doing this in general is that because I ask it for this summary, that this response to this summary changes the names that it will return, because now summary is part of the context. It's part of the response. Output tokens are part of the context, which is wild. And similar, summary also impacts places, and names impacts places as well. And so you end up with this challenge where, say, I don't know, I ask it about how well I did in something, right? Say I ask it like those 3 questions. The problem is the order that you ask these questions in greatly determines what you get for each of these responses. If you ask it about just the good things and then how well you did, it may actually tell you more likely that you did well, right? Similar, if I just asked it about the bad things and asked it how well I did, it'll again mostly lean into the bad things because it just told me the bad things, right? And then similarly, if I ask it like this, it may not come up with that many bad things, right? And so now that we have this ability to cache on this context, and what we're able to do is actually call the AI model 3 times. We don't need to be as specific about what we're asking for. We can actually just say, hey, I'm going to call it once for the summary. I'm going to call it again for the names. And I'm going to call it again for the places. And this is optimized now, which is like wild, right? We're actually able to make this more efficient by making more calls to the LLM, which is awesome. So anyway, huge benefit. I'm super excited about it. I've been thinking about this for a long time too. And Gemini had previously come out with this idea, but more recently, Claude has made this super user friendly. With Gemini, it's fine. It's a very Google Cloud way of doing things. You got to set it up in the API and make the calls a certain way, and by default it charges you per hour. And the Claude pricing is just so much easier to understand and manage. It's much less enterprise and it's much more user facing. So anyway, I like it. But let's go through it. Effectively, the way that you use the prompt cache is you basically add a little like cache control here. And then this is going to be a cached value that you have in your prompt request. And these are all the benefits of it. So if you start using caching, you get these benefits. Write to the cache is expensive, but reading from the cache is really cheap. And we'll talk about the specific pricing on that later. Right now, we're limited to around 1024 tokens on Sonnet or Opus, so the better models, and 2048 tokens on Haiku. And the cache lasts only 5 minutes. So let's look at an example of this. So say I've got some game rules that I care about, and I've got a current game state, right? And I'm basically running the LLM. I'm saying, hey, I've got my rules, I got my state. I want to know what the next move is for the game. And when we send this through, to write to the cache will cost 30.75% of a cent, but reading from the cache is 0.00003 cents. 0.003 cents, yes. And so it's a very cheap read, and it's a little bit more of an expensive write, because the regular write, of course, if we were just going to write it normally, you can see reads are definitely cheaper from that base price, and the cache write is a little bit more expensive. So then what does that mean? So it means basically for this request, if we're just looking at this chunk, in the first request, if you're just going to ever make one request, caching is of course going to be more expensive. But the minute you make 2 or more requests, you immediately have a return on your investment. It's immediately cheaper. And so this is amazing. This is incredible. It's a feature that immediately makes your code run better. It allows you to do some really cool things with context to be able to pull things out a lot better. And like over time, I'm sure they're going to expand how much can be written to these caches, increase these limits over time. And so this is just the beginning of being able to do some really amazing stuff inside of Claude. Pretty exciting. If you did need a more enterprise thing, of course, Gemini offers this in a different way. But I think this is definitely a game changer for how to think about RAG and RAG systems. Because, hey, we're going to get some like pretty cheap context doing this. It's really cool. Last but not least, let's talk about hype and machine learning. Everyone responds to hype a little bit differently. And this is my mapping of it. It's a very rough map. It's probably very inaccurate, but it's just how I've been thinking about it over the last month or so. Effectively, you can choose to ignore it. Many people do, and that's fine. But there's also a group of people that, of course, are making money making content. I'm not making very much money on this. Actually, I'm not making anything yet. This is still a very small channel, so I'm just putting in my time because I like talking about it. So I'm not really in this camp, but There are a lot of people in this camp that are making courses, they're making money. They are riding the hype wave, so to speak. Then there's, of course, like discussions of forums around the hype, people who want to really voice their opinions about it, but don't really care that much about getting directly involved. They're just excited to fuel the fire of some conversation happening. That's cool. Then I think there's a tendency to gatekeep with technology, to use this kind of technical knowledge to push back against hype, which I think is a very natural tendency for engineers. I think some people like to look at AI and this hype and try and really want to understand it. I think I generally fall into some of this category, but much more the latter, which is this, I want to experiment and productize and see, okay, yeah, there's this cool thing coming out. It makes me think I may not know anything, but I want to experiment with it. I want to productize it. I want to see, okay, but what is this capable of? What is the truth of this? And so that's where I fall in. But I think it makes sense that people fall into different places. It's just your natural tendency of who you are and what you care about. And so when we think about a topic like fine tuning, there's a lot of differing opinions about it because people are coming at this hype from different perspectives. I look at fine tuning and I look at what a lot of the industry leading companies are doing, and I see it as it's a very sellable thing right now. It's something that people feel like they need to do. I don't see a lot of return on it when I've looked into it, but I can understand why people might want to do it. And so for me, when I've experimented or looked at productizing, it just hasn't made sense. But that's how I'm responding to it. I've dabbled and I'm like, I think I can do enough without it that it doesn't matter that much to me right now. So that's where I'm at. I want to really touch on the gatekeeping end of this. So I saw on LinkedIn recently, there was this post. I'm starting to suspect that the vast majority of people who are working in AI will never have implemented a single ML model, not even a toy data set, right? And I think, and I replied, I think this is true. It's probably a good thing. I think there's this tendency to see a new group of people coming into a familiar space and want to distance yourself from a challenge that they're presenting. Some of this is this hype, right? And I don't like hype. I think most engineers don't like hype. This kind of overemphasis on things that it starts to differ from sort of your core values, right? And when you start to see that, you start to like question, okay, why do we have this? And I think this is a great observation. I think it's totally true. From an engineering perspective, though, it can become a gatekeeping type statement, right? It can be like you're not a real programmer. You're not a real programmer if you haven't written your own compiler before. You're not a real programmer if you haven't coded your own language and coded in your own language before. That really shows you what programming is, right? And cool. I think there's a group for that. That's great. I think it's also like a good thing to value is the hunt for knowledge and the rigor involved in that. I don't think that you need that in order to be able to work on AI stuff. Overall, I think just be careful about which one of these you naturally fall into and just try and think about, okay, based on me, based on what I want and how I'm falling into this, is that the place I want to be on this? Do I just want to ignore it and not care about it? And that's cool. I think there's a lot of this that you won't be making money on it, and that's fine. If you want to make a huge buck on AI content, it's already really competitive anyway. It's hard to get into. It feels like everyone's doing it and everyone's making a bunch of money, but it's questionable. If you just want to discuss it, that's also great too, right? But there may not be a lot of substance there because I think some of the folks over on this side are the ones who probably have the most real world acting understanding. And so I try and aim over there more. I try to inform this group. I try to observe this group, but I'm just not that interested. But I'm mostly excited about, okay, what are people thinking about when they're actually working in this space? What are people trying? What are things that resonate with me and my values, right? I think I'm much more down here, right? And so I observe some stuff that lives in the academia, some stuff that lives in the deep data science space, but most of my focus is on experimenting, product, building stuff. And so that's what I'm going to continue to do. And if you enjoyed this, and you want to find out more about us and what we talk about, you can find us there, blog.stablediscussion.com. And I'd love it if you would follow us, subscribe, like this video if you enjoyed it, and we'll catch you in the next one. Thanks so much.